introduction on myself?
Go ahead, Joe. You're live.
Thank you. It's a pleasure to be here with you tonight. Thanks for inviting me, and it's good to see you guys once again. My name is Joe Detomaso. I'm with the Donwil company. We're a representative of Liebert Vertiv, and we rep Atmosair, which is bipolar ionization, Hitachi, VRF, and mini splits, and Liebert. Those are our main lines. Tonight, I'm going to talk about our pumped refrigerant system that has been very, very popular. And then I'm also going to talk about containment, which is another system that has been very popular in the computer room. Does anybody had any experience with containment? You guys? Nobody?
That is.
Okay. All right. We'll get into that in a little bit. The first thing I'm going to do, though, is talk about. Sorry about that. Did I get the wrong presentation up there? Something happened.
It's old.
Yeah.
Wonder why it wants to.
Crazy, that's 2.5 years
Going the
ago.
wrong way?
It feels like 10 years ago. Feels like yesterday.
All right. So a few years back, you guys have been around. You remember we used to have cool systems, which was basically extra coil in the unit that we would circulate chilled glycol through, and we would cool the computer room like that. So it was pretty efficient for its day. It was pretty popular. The only thing was that you could only economize or get free cooling when the temperatures were below 30 degrees. 35, something like that. And then you always had to have the glycol, the right mixture. So years ago, we repped a company called HiSave, which was a pump system that they put in the liquid lines, and it would lower the pressure of the discharge of a compressor, and we would save energy that way. Well, Liebert's engineers took that kind of same idea and took it another step and said, what if we could pump the refrigerant, shut the compressor off, and just pump refrigerant? And how much money would we save then? We'd save quite a bit if you didn't have to run a compressor, and all you had to do is run a pump. So that's basically what we do. They're called the Liebert DSE, high efficiency data center cooling, and they basically look like a normal Liebert unit. A few differences. We'll explore a little bit of that, and then I'm going to talk about hot aisle, cold aisle practices and containment. But here's our sizes, what they come in. 50, which is KW. All our model numbers now reflect KW. Whereas before, if you had a 199A, that would be 199,000 BTUs. It would be like a 15-ton unit. Now, if you see a Liebert unit that says 85, that's like 22, 24 ton. A 50 would be like a 10 ton. So you just do that conversion. Does everybody know how to do that? 3.4. That's right. That's right. So you can figure that out pretty easily. I like to use that conversion if you walk into a computer room and you have to figure out the load. All right, so the best thing to do, since anything that's in the computer room is drawn off of the UPS power, like their servers and whatnot, if you go to their UPS and you see what the KW draw is, you can pretty much figure out what the load in the room is. It's not gonna be exact, but let's say you got 100 kVA UPS. You go to that UPS, you say to the guy, the IT guy or whatever, hey, can you tell me what the KW draw is on the unit? He tells, yeah, I'm drawing 45 kW right now. You take that times 3.413 and that's gonna give you your load basically. So that you can tell in BTUs what you actually have. Now it's not gonna take into consideration any external loads, you know, like that we would normally figure when you're doing a load calculation. But let's say the guy says to you, you know, I need to add a 20-ton unit, okay, because I can't keep the place cool. So first thing I do is ask him, where's your UPS? How big is it? How loaded is it? So he comes back with, you know, tells me it's 45 kW. So I can convert that to BTUs. Then I know if he needs another 20-ton unit or not. Because remember, we're designed for mechanical cooling. We're designed for heat. We're not designed for comfort. Sensible cooling. Okay? So, if I have 45 kW, I know I probably got, what, under 10 tons of load? And I can kind of size it that way. What most people make their mistake in computer room stuff is that how they lay out computer rooms with the racks and where they actually position the air conditioners. So in this case, you see they have the perforated tiles here on the sides, which is pretty good. And then this would be like what they consider a hot aisle. So the servers would go in from the front, as they're kind of shown there, take air in from the front, exhaust out the back, and then the heat goes back to the return. So that would be a typical cold aisle, hot aisle. And that's how we want to set up rooms. And the reason I bring that up is that customer says I need 20 tons of air conditioning. We don't do any investigation. We put 20 tons of air conditioning in, and we still have the same problem that we had before. We're just throwing 20 tons of air conditioning at it. We're not solving the problem. The problem doesn't go away. The problem is, in this case, this unit's sucking back cold air along with the hot air, and the unit satisfies. Shuts off. Yes, sir.
Are you saying you don't need, when you say sensible cooling only, you don't, the humidity doesn't enter into it?
It does, but it's not as much as it used to be. So these manufacturers of these computers, servers and all that,
Yeah.
their range is like 20 to 80% right now. Sometimes even higher and lower than that.
Okay.
But it really doesn't play as much. And we'll talk a little bit about
So
that.
you don't have to have 50% all the time?
Not typically anymore,
Okay.
but in some cases, you know, some people are very particular about static electricity, so.
Right.
That's why they wanna keep the 50%.
Anyone I ever had that did the cooling, brought the humidity down, they had to put a humidifier on there to put it back in.
Yeah, yeah.
That's what we did.
Or a heater, right? So the way we dehumidify is we have to run the compressor at full capacity. And does anybody know why we have to do that?
No.
So we'll just get off the beaten path here for a minute. Because any precision air conditioner runs about 150 CFM per ton more than like normal air conditioning, we don't dehumidify when that unit's in cooling. So what happens is, consequently, it's kind of a blessing too, because we really don't want to pull the moisture out of the air. But in order for us or precision air conditioning, no matter who it is, to dehumidify, we have to get the full capacity of the unit. So what would happen if I'm already at set point at 72 degrees and this thing says I need to dehumidify? but the customer doesn't have the load to support the cooling, you could see what would happen, right? Temperature would go down.
Right.
And would keep going down, and then you'd have a major problem on your hand, because once you get below 68 degrees, you look on a site chart, humidity actually starts to go up. So it actually snowballs. So what you try to do is match this equipment as close as you can to what the load is. And if you do that, the reheats in the unit will stabilize the room air temperature. And that's the only reason we put reheat in our unit, is to stabilize room air temperature. That kind of makes sense, right?
Do they do, atomized water for the cooling, to help with the cooling?
We just came out with that. I might show you some of that in this presentation.
Tremco adamantly refused to do that.
Yeah.
They just
We-
looked at the.
Well, here's the thing. A lot of people say, well, I can do free cooling for a computer room. And I can use atomization, I can do some kind of water, I can open an economizer, I can put a air handler on with an economizer in it, bring in fresh air. What happens when you do that?
You bring in humidity. if it's
You bring in
summertime.
humidity, or you're bringing in real dry air, right?
Right,
Consequently, you're gonna make that Liebert unit work really hard and go like this, because it's trying to satisfy whatever you're bringing in. So that's why on an unmanned computer room, we tell everybody, no outside air at all. Nothing. Some cases you have to have it, because if it's a manned computer room, then you're gonna have to have outside air. I'll tell you a funny story. I used to be a guy that used to carry the tools, and we had a unit down at the Pro Football Hall of Fame. They installed this thing, and the complaint was the unit was all over the place, going like crazy. And it was like a Challenger unit, you know, the 35 by 35 inch foot Challenger. So I go in the room, and I see the unit, everything looks fine. I open up the door to the unit. There's a filter on the back of the unit. And what's on the other side of the filter? The outside wall. Wide open. What a grate. And that's how they introduced outside air into the space. There's the sensor sitting right here. Here's the return. And they want to know why the unit wasn't working properly. You know. So in that case, we had to tell them, first of all, you should really consider doing it a different way about bringing the outside air in, but take the sensor out of the unit, let's put it on the wall.
yeah.
So, it's funny, you'll see, you
Condition-
guys know, you've been out there, you see all kind of crazy things that people do, right? So just little side story, that's all.
Today.
Huh?
Saw one today.
Yes, yeah, exactly. I got another story for you. Guy called me up one time. He had mini mates he put in. They were like 30 foot up. He says, you better get down here. He goes, every time I buy Liebert equipment from you, it's nothing but junk. It's high priced and it shit don't work. And I go, yeah, okay, I'll come right there, right now. I'll leave what I'm doing.
What do
And
you
I
do
did.
it for?
Huh?
What do you do it with?
Yeah.
Yeah.
So, you know, he says, yeah, these things, he's got a bunch of people standing around too. And this was like for Cleveland State or something. He said, yeah, these things, you know, I'm tired of working with you guys. And well, I'm keeping my mouth shut because every time he's called me, it's been his installation problem. So I get up on this huge ladder, I go up into the ceiling, I look at the unit, I come down off the ladder, and I say, can I talk to you in private? And the guy says, anything you got to say to me, you can say in front of all these people.
Oh, boy.
So I said, you know, you gotta run power to these units to make them work. He never had the electrician never ran the single phase power to the units. He had the thermostat hooked up on the wall and it wouldn't come on. So he goes, what the hell, this thing is junk over here. And this was a guy that was buying equipment from us. Finally, we had to tell him, if you don't start working with people that know what they're doing, we're not gonna sell you any equipment. And I gotta sell them to him, you know, I can't refuse it.
Wow.
I'll bet he crawled into a hole.
Yeah, he did.
Power.
So I sent him a nice bill for that. And that stopped it. Once he started getting bills from me, I was being a nice guy by just going there every time. And I figured if I don't do something, this guy's just gonna keep doing the same old thing all the time. Because what he would do is like a broker. He would win the job and then he'd hire different, companies to put shit in. But he would never check on them to see if they actually did. The guy just said, customer says the units don't work.
Homer and Gomer.
Yeah. So, it was crazy, yeah. Alright, so hot out, cold out. Remember that if you go in a computer room, try to identify this and see if they have this set up. If they don't have this set up, a lot of times what you'll see is a unit that's bringing in cold air, exhausting hot air. Then this unit, these racks, they wanna suck in cold air, but they got these actually in the wrong configuration.
Yeah.
So this one's blowing cold air, hot air out, this one's sucking in hot air. And they can't keep them cold. So that's a way to identify problems. They say, I can't keep my servers cold. There's all kind of these little things when you go into a computer room to look for. So I got off the beaten path a little bit there, but kind of remember that, cold aisle, hot aisle. This isn't bad, So what you want is that hot air right in the middle to come back to the unit. And what if I put I'm gonna talk about this in a little bit. What if I put containment here? What if I enclose this and kept the cold air so it couldn't go anywhere else but through the servers? You think that'd be a good idea? Anybody?
Sure.
Yeah.
Yeah.
Yeah, so this is what, instead of, this has a little quarter horsepower fan in it, these little servers. This thing's got a 20 horse motor. What's gonna win? This is gonna win. It's gonna pull the cold air along with the hot air. So we got this mix, and if the sensor's sitting right here, what's gonna happen? This unit's gonna say, I'm satisfied, I'm gonna shut the cooling off,
Measures.
and I'm gonna get this big, it's gonna short cycle and all this stuff. So just kind of remember the layout. So if you walked into this room and these were regular Liebert units, and the guy said, I gotta add 20 tons of cooling, and you would say, maybe. You mind if I check some stuff out first? Okay? And then if you feel that you have this problem, that's when you would call me, and I would come with you, and we'll figure it out. Or you could tell them, you got the wrong configuration here, you're sucking cold air back to your unit, and that's the problem.
Yeah.
A lot of people don't see that. Still today, there's rooms out there that were designed in the 70s and 80s that are still running the same kind of configuration. They've just updated their servers and equipment and put them right back into the same way they were. Then it creates a big problem. So just be observant, that's all I'm telling you. All right, so let's go back, and now that I kind of got off the beaten path, let's go into this DSE system. So remember I told you that we're kind of looking for better economization. So we can economize at a better temperature than 35 degrees, all right? So here's your basic indoor unit, right? Then you have the ICOM control, which you guys are gonna see at the post office. Then you have the microchannel condenser, okay? And then there's one piece that we're adding in here, which is the econophase pump. That is pumping liquid refrigerant. So here's an example of actually what we're doing. So again, your indoor unit, your condenser on the roof, your pump, and what we're showing here is an outdoor temperature of 95 degrees and a cooling PUE of 1.28. So this cooling PUE is something that the IT guys and engineers are trying to get this as close to 1 as possible. So on a 95 degree day, no economization, Both compressors are on, they're drawing 8.5 kW apiece. Evaporator fan is 3.2, and the pumps are doing nothing. Condenser's 3.9. Now, we go to a 65-degree day. We could actually start to shut off compressor 1. Compressor 2 is still working. Evaporator still working. We have a pump on, moving refrigerant in circuit 1. It's only drawing 0.6 kW. The pump 2 is off. And here's your basic refrigeration cycle. If we go to a 45-degree day, again, this is depending on what's going on in the room. On a 45-degree day, we can run both pumps and we shut both compressors off. And everybody says, how can you do that? When you think about it, we're just pumping refrigerant like the compressor does. Still have a change of state, but we are cooling that down with the temperature outside.
45.
Yep. To get where we need to be. So, the condenser has to be elevated with at least like 36-inch legs, so that we have some fall coming to the pump, so we have liquid coming here, then liquid coming back down to your expansion valve. That's all controlled by electronic expansion valves. So you could see that this unit here, even though it costs a little bit more money because of the extra equipment that's built inside of it and the technology, has a payback of about 2 years. And any customer that's trying to save energy, which everybody is, they love this equipment. So you can walk right up to the front panel and you can see how many hours the unit's been in compressor modes 1 or 2, and you can see how much it's been in economization. So right there, it tells the customer instant feedback, what he's saving. So a unit that used to cost $6,000 to $10,000 a year to run is probably costing, in Cleveland, where you have a lot of days under 65 degrees, probably costing them $2-3 grand to run. So the big thing is though, the extra cost. If they wanna pay for it up front, go with this DSC system, regular DS. It's gonna cost them, say a regular DS now is, do you remember what they were for the post office? How much? Was it like 70 grand a piece?
I think it was more than that.
Yeah,
Yeah.
so let's just say they're 70 grand a piece. This would be like 150 grand a piece.
Oh,
More than double.
Yeah, well, yeah,
Yeah.
maybe not that much.
So when you said the ROI with 2 years on it, do you mean the difference between the two units was?
Yeah, return on investment that, between the power that they're saving and the bill, electricity bill, and I'm just throwing numbers out there. That's what I'm talking about, the
Not
return on
the
investment.
whole project though, just the difference between.
Yeah,
the
I
two.
don't know about that, you know, it's operating costs.
Gotcha.
Any questions on that? A lot of people are like, how can you run a pump to move the refrigerant? Well, I'm surprised somebody hasn't thought of it a long time ago, to be honest with you. But I think,
Basically, it's just keeping a solid.
what's a
column of-
compressor? It's a pump, right?
Yeah, keeping a solid column of liquid.
Yep, yep.
So what does PUE stand for?
yeah.
Power usage effectiveness.
Okay.
So it's these computer guys, IT people, and engineers have this formula, what it costs to run a data center versus, I can get you a good definition,
So
instead of me screwing it up.
Basically the KWAN versus what you're getting in return for it.
Yeah, yeah.
I got a question for you.
Yeah.
Your pump, that you're using a pump to move Freon,
Mm-hmm.
right? You gotta have a seal on that pump
Yeah.
to move so I mean, does that seal ever leak or
We haven't had problems like that.
no?
No. We had more problems with glycol pumps leaking.
Oh, yeah.
How many times you go on a glycol unit and they're always seeping, always
Yeah.
weeping, right? Because somebody started them with, dry, or somebody let the glycol level get too low, or whatever the case may be. We've had more problems. The warranties on those pumps, if you walked over to our shop right now and went in the back room, you would see a ton of semi-hermetic compressors. You would see a few digital scroll compressors. You would see none of these pumps. And now these fans, these up here, these are EC fans. They're electrically commutated fans. No more like P66s or VFD drives or any of that stuff. So that's all changed. Can somebody look at this picture here and tell me what's kind of different about this picture? I'll give you a hint, it's in this area right here.
It's elevated off the floor.
What's that?
It's elevated off the floor.
Well, yeah, this is a floor stand here, but that's not what I'm getting at. Take another look at that. See what you think.
Are those fans I'm seeing?
Huh?
Are those fans that I'm seeing?
Yeah, so these are fans down here,
Prop-
right?
Prop fans, yeah.
These are actually the evaporator
Oh, I
fans.
see the back, okay.
Yeah.
I see the.
So what we found, by taking the fans and actually putting them down out of the unit into the floor, we can increase our efficiency by almost 5%. Is that crazy?
Doesn't look like it going to the floor.
Yeah, well, remember, the floor would be right here.
Oh,
In the back.
oh,
This would be the floor stand,
uh-huh,
and if you have room to put the fans in the floor,
uh-huh,
that's the way to go.
uh-huh.
So here it is. This is more efficient than chilled water, believe it or not.
Myron?
All right. So, the DSE, we'll go a little more in depth in here. Guys showed no water usage, no water treatment, no outside air contamination. Remember we were saying about outside air, we don't want outside air in a computer room. No dampers, louvers, or any of that stuff. So, over here, they're talking about the system power usage. I can give you this if you want it, so you guys have it. I don't expect you to remember this. The thing to remember is that this is a pumped refrigerant system that can start economizing below 65 degrees. And if you're in Cleveland, Ohio, how many nights do we go below 65 degrees? Even in the summertime, right?
Just a couple.
Yeah, just a few, just a few. So here's a chart that tells you about econophase hours, and here's a temperature below, and above. And showing all that blue is definitely all economization. Here's a range where you're, iffy, and then here's a range where you're not. So sometimes they're saying 28% compressor. In these load calculators, let's say you had a customer that had a few of these normal lever units that are maybe 20 years old. He wants to replace these units with something very energy efficient. Then we can propose this and we can show them the savings. So if you ever get into that, just let me know. So this is what the smallest one that comes in, it's 50 kW, single compressor circuit design. Basically it's, like a big glorified Challenger PDX unit. I'm not a big fan of single circuit units. Something else that we do as a factory, we will build these condensers on skids. So if you did have a large project, this would save you time and money. And all you have to do is hook up your piping to the indoor unit. So you see, in this case, they got the skids built, we got the pump there, condenser. So we can do that for you. Any questions on these DSEs? You guys wanna talk a little bit more about them, or have any questions? We actually make them in really big sizes now. We make them as big as an air handler, and I'll show you something about that real quick. But fire away if you got a question.
Size of your refrigerant lines, are they larger?
It depends on the length of your runs. So when you come to me and you say, I got 150 feet of run, then I'll help you design your refrigerant lines, taking into consideration, you know, how many bends and stuff like that you have.
Is there a vertical limit
Not on these.
on the
It used to be.
Yeah.
And it used to be that we could not put the evaporator above the condenser. We could only go 16 feet. Now we can do a lot more than that. Let's see if we have a couple better pictures. Now this might be interesting to you guys. So that's what the condenser looks like. So their microchannel almost looks like a radiator on a car. So so all you guys out there that used to work on condensers can tell me that if that's an actual condenser picture, you ain't working on that, right? You're not fixing that.
No.
So if you got a
Micro channel, good luck on that.
yeah, you gotta replace the whole coil. That's the drawback that I see, and also cleaning them, when you clean them, they'll hydro lock on you. If you just spray water on them, they will hydro lock on you, and then your unit will keep going off on head pressure. Now, Liebert built in,
Hydro lock.
Now, what's that?
Hydraulic.
the coil will actually saturate itself with water, and you won't be able to get any air through them.
Uh-huh.
Liebert puts in here that these fans that are on here, you can actually turn them and drag the water down out of them. They do the same thing with the indoor unit.
So capillary actions, what's,
Yeah, I guess, I don't know, whatever you wanna call it, I call it hydrolock,
Okay,
so that, like, almost like a refrigerant piping too, sometimes you get that where you can't move refrigerant.
well, the
Unit
fins
goes
are
off
too
on
close
head pressure.
together.
Huh?
If the fins are too close together, then it
Won't
blows
drip the
up.
water out. Water just hangs up in there.
Yeah,
And that's what these are, it's like a radiator in the car,
It's
right?
sponge.
See, almost doesn't blow it
So
out
what's the
with air.
solution to that? The fans?
fans.
There's a certain way to clean them,
Okay.
or use that redirection where it blows the water out after you're done. If you walk away, let's say if you hose them down, you use your cleaner, you hose them down, you walk away from it, most likely you're gonna get a call back that the unit's gone off on head pressure.
Huh.
So do you
That's
have,
what the fan looks
do
like.
you have the process for cleaning those?
Yeah,
Blow it out.
it's in the book.
Okay.
I don't, off the top of my head, I don't remember, Tom, cause I actually never worked on these, All they do is sell them now.
Yep.
So variable speed fans, but they're EC fans. But here's a big thing, it's like, look at the weight difference. For a regular fan, fin tube condenser, 670 pounds in this particular model. In a MC, a microchannel, 400 pounds, so you're saving 40%.
Wow.
So that means, these roofs and all that stuff, and where you're gonna put these things is, transporting them up across roofs and stuff like that is much better than the way it used to be. I'm still a big fan of, if you got a problem, you can cut a section out or repipe a condenser, whatever the case may be, but they're just not as efficient as this new stuff. So, you know, not everything changes, right? Alright, so we talked about this already. Here's this program that I'm talking about. So comparing the Lieber chilled water unit to DSE, column phase. Can't really read the numbers here, but we can do this for you. And it'll, actually the printout that I give you will be just like this. So over 500 units, this presentation's a little old, it's probably 3-4 years old, let's see if there's a date on there. That's when I saved it.
I think it was 20 when we were going through.
21.
You wouldn't think it'd be very popular where it's hot all the time.
Yeah, so check these out, San Diego, of course, San Francisco, San Diego, cool, nice, but up here Washington, look at all these.
Yeah.
Over here in New York and in Maryland, Delaware, where the Navy's at, the Navy was one of our first customers they said, well, we like your story, but we don't believe it. So they said, we'll buy 1 unit and we'll see what happens. So they bought one, put it in, I think they let it run 6 months. They ordered 30 right after that. And it's been crazy since
Off the
ever since.
races, yeah.
Yep. Typical installation. See the tall legs on the condenser?
Wow, yeah.
Now this picture makes it look really big, but if you look at so this is an air handler here, right? I mean, so this one is, it's not that, for some reason it really looks big.
5 or 6 feet up.
Yeah. Yeah, and then here's the pump.
So they're doing that to get the height
Yes,
from the pump?
yeah, get the gravity feed back to the pump. Talked about that already. I think that's all I have on that. All right, we're gonna talk about some containment next. So here's this is a typical layout for server racks and a computer room. And right off the bat, you see a couple things, right? You see that we have doors, and then we also have a roof.
That glass roof?
Yeah, it's like a plexiglass.
Yeah.
So when you get into this kind of thing, what you gotta worry about is fire codes. So a lot of these rooms have sprinklers and whatnot. So depending on where they're and what type of fire suppression they're using, we have to take that into consideration. So these panels though are made of like a plexiglass, but on these ends in here, what happens is if the temperature gets above 130 degrees, the panel actually falls away from the aluminum. So it like melts and shrinks, falls so that the fire suppression can work. Some fire codes say that's okay, some they want it to be instantaneously. So they don't want you to use this. But I would say the one biggest thing is this right here. If you did this, let's say on that drawing I showed you before, if you were to put a door, let's say if it was, picture this. Here's that row of racks, right, that I was
Yeah.
talking about?
Yeah.
Cold aisles here. And if you enclose this, the cold air has nowhere else to go but through the rack. Cool the server down, the heat comes out the backside,
Yeah,
goes back to the unit. So now you have the room is like a return air plenum. So the room is probably 75 to 80 degrees. But in this aisle here, you're gonna be in the, 60, something like that. You can see how by doing this, you're gonna stop any short cycling of the unit. Even though we've taken precautions to stop short cycling with digital scroll compressors and things like that, there would be no short cycling here because you're just delivering heat back to your precision air conditioner. So in a case where I had a customer that had kind of a setup like this, but no containment, and they had an air conditioner back here, no other equipment back there. And their complaint was that they didn't have enough cooling in the room. But yet you go in the room and that unit that's back here,
it's cycling,
yeah, it's off all the time, really.
yeah.
So what do, and these are, remember, these are not mechanical people, these are.
No, they have no clue.
Right. So it's your job as the technician, you're the advisor, to tell them what's going on and then show them what's going on. Somehow, some way, you tell them, listen, if you put doors at the end of the aisle to contain the heat or cooling, what's gonna happen? And then that unit over there is now can be maybe put on a rotation with the rest of the units or something like that. Or just let it run because the whole room's now a return air plenum.
So if
So
they
we
want-
try-
They wanna add more cooling,
Mhm.
and the unit is cycling
Mhm.
or off half the time.
Well, they think
Why do you want more cooling?
because they have,
I know,
No brain.
exactly, exactly. You got it 100%. But so you got this room, we got this room like this, okay? And over here, it's like freezing cold.
yeah,
This unit's just kind of like bumps out every once in a while. But then over there in that corner, it's like 100 degrees. We can't keep it cold enough, right?
right. We need a bigger unit.
Yeah, I need more air conditioning.
Mm-hmm.
I got another air conditioner here. Well, it's too far away. I can't get it to do anything. Well, if you do it right, you got more than enough air conditioning. You're probably going to shut half of this stuff off.
Yeah.
So that's why using containment is really, I can't stress it enough. It's just huge. The reason for the roof, putting a roof on here, is that you will get this overlapping. So if this is the cold aisle, this is actually the hot aisle. But if this wasn't here, you contain this, and you have perforated tiles that are blowing air up, or in this case, they have units that are in the row. That air, believe it or not, will come over the cabinets and then make it shut units off. So that's why we like to put a roof on it. But if we're doing one thing, I would either put a door or a curtain here. Stop that air from coming. So they have all kind of different things you can use. Let me show you another slide. A little PowerPoint from, we rep a company called Sub-Zero, but there's so many companies that make this stuff. All right, where'd you go? Just had it.
Something else? And they're not in alphabetical order?
Yeah, they are. And that's why I went directly down here. And I must have put it in another,
Call it something different.
here we go. There we go. I had it under Sub-Zero. Imagine that.
No,
What a coincidence.
Alright. So this is the stuff we rep, but there's so many companies that make this stuff, so I'm just telling you about it. I'm not here to sell you anything. I'm just here to tell you what the concept is and show you how it works. So, again, how your aisles are set up right here, different. You can do a single row, you can do a double row, again, a single row, put like a cube on the end of it. Anything we can do to contain that cold or hot, so you can do it either way. You can do it in cold aisle, or you can contain the hot air. And just depends on what do you think is more efficient. I prefer cold aisle containment. And then the customer can put their, you know, these are electrical distribution for the racks. And this is all kind of another kind of system, but aisle frame they call it. But that gives you an idea of what this stuff looks like. You really don't need all this. This is just something that they came up with. So typically there'd just be a roof there. Let's see here. So they have a sliding door you can use, which automatically opens and then it'll close by itself. Or they have hinge doors, sliding doors, auto closures, hinge doors, anything you could think of. A lot of people use curtains. I don't think I show curtains in this one. But this,
Like a air curtain?
yeah, like almost like you see at a freezer, like
Yeah.
a
Indoors.
Giant Eagle or something like
Right.
that. The only difference, I think, is the material is not as heavy that we use. And the other difference, if it's a curtain that's hanging, let's say it's a curtain here or here, and it's supported off the drop ceiling. Coming off the drop ceiling, there is a link, like a fusible link, and it's designed to go at 130 degrees, so if you do have a fire, gets 130 degrees, boom, the curtains fall. You really gotta be careful with the fire department. So here's curtains, that's kinda what they look like.
Oh, like hospitals,
Yeah, see these, yeah, exactly.
ERs.
See these right here, these fusible links, and they'll hook right to, you can hook them right to the drop ceiling, or you can hang them with unistrut with threaded rod. But can you imagine how much money, if you're, let's say your customer thinks he's gotta buy a new air conditioner, and of course, we all wanna sell air conditioning, but you sell a new air conditioner, it doesn't work, he's probably not gonna call you again, right? He's gonna say, man, you took $150,000 of my money and I still got the same problem. But if you went to him with this solution and told him, listen, I can fix your problem by selling you something for maybe installed is 50 grand or 60 grand.
Yeah,
And he's gonna be a happy guy.
yeah.
Not gonna have all kind of electric bills. His room's gonna run right, everything's gonna be come in a kind of order, so to speak. And it's just the way to go. Unless you get into that room where I was talking about before, where, you know, all right, here's hot air, or here's cold air, you're blowing hot out the back, and then he's got another row here of racks, and that's supposed to be cold, but this guy's, all this whole row is, imagine that, this whole row of racks is throwing hot air out, and he wants cold air, you guys want cold air, right?
Yeah.
And they got it set up wrong, but what are you gonna do, because you can't do much. It's been that way for years, the IT guy's not gonna wanna change it all around. So we gotta come up with some kind of solution where you may just do this. And then they'll say, well, you know, I don't wanna spend that money, and how serious are you really about
Fixing the problem.
fixing the problem? So here's another problem that a lot of people overlook. So this is called their cube. Let's say I'm standing on a raised floor, And at one time, there's a room next door to this, right, Tom?
Yeah.
You got a storage room over there or something?
Warehouse.
It was all raised floor at one time, the whole place. But now the computer room's only this big. I got a Liebert unit there, and I got a Liebert unit there. Raised floor, that's still a raised floor over there. That's still a raised floor. Nobody's done anything. So now I'm conditioning all of that still. And I'm bringing back unconditioned air that's siphoning in from regular house air or whatever. So if the customer doesn't realize that, you could fix that by using these pillows, by putting these pillows under the floor, line them up, or you build a wall for them with Visqueen and all that good stuff. So that's why I say when you walk in a room, you gotta take in the whole room and see what's going on in there. Because right away they're gonna tell you, that Liebert unit's junk, it don't work. It can't control humidity. It's always crazy. You know, the humidity's high in the summertime, low in the wintertime. Well, what's that tell you?
Infiltration.
No vapor barrier, right? I had a customer, and I don't mind telling you, it was Everready battery. This is when I first started carrying the tools. This is back in like 91 or 2 or something. Anyway, my boss calls me up and says, hey, go out and see this guy at Everready. He's got a problem out there. The unit cannot bring the humidity up past 35%. Well, back then, the units, that's as low as they would go, was 35%. So it really was probably like 20% in the room. So I just had bought one of these Dixon meters, you know, the
Yeah.
handheld humidity meter, and that's, again, years ago. So I'm green at this point, but I kind of knew enough, had been around enough to know that about this humidity stuff, and somebody had told me about airflow. And we all learned that one of the first things we learn is about proper airflow, right, for a room. So I look around and I'm looking in the room, and guys yelling at me and saying the thing's junk and they want their money back. So I said, okay, give me a minute, please. I look at the floor. It's a carpeted raised floor. They used to do that, right? Back in the 70s and 80s, they had carpeted raised floors with maybe a perforated tile here or there. Well, our rule of thumb is 1 perforated tile per ton of equipment. So if you got a 10-ton unit, you should have at least 10 perfs, full perfs, okay? So he's got like 5 in the room, and they're not perfs, they're like a register for a house, cut into the floor. So I asked the IT guy, I said, you know, well, let me back up. I took my handheld meter, I had like 15% in the room. And the Liebert unit, the first thing I did was I checked the Liebert unit out, make sure it was pulling the right amperage, tray had water in it, it's trying to do everything it can. So we only had 15%. So I stuck this meter, I got down there, pulled the floor up, put the meter under the floor, I had 85% humidity under the floor. So I went over to the IT guy, I said, I want to try something. I said, I'm going to take 5 tiles, I'm going to pull them up, let the air circulate in the room, and let's see what happens. He goes, listen, he goes, you can do whatever you want. He goes, but that's not going to fix the problem. I said, fine, okay, just let me try it. I just want to let you know because I don't want people walking in these holes in the
Oh,
floor.
yeah,
Right? So we did. I pulled the tiles up. He even
Whoa.
helped me.
yeah.
5 minutes. 5 minutes, not even 5 minutes.
50%.
50% humidity. The unit came out of a call for humidification, and the guy looked at me like I was a magician or something. And here I was, a pretty green kid, but I had learned enough working with this stuff every day. I knew, and I had gone through like the Westside Institute and stuff. You learn about your basics, about airflow and all that stuff. So I just put all that together, and the meter really was I would have never tested it. 85%. And so after that day, I became like a little bit of a star in my boss's eyes. You know what I mean? It was like, cool.
At Tremco, we had a research lab that was 100% outside air. I've seen over and over again, 12% relative humidity.
Yeah.
Cause it's 100% outside air in the wintertime when it's 10 below zero.
Somebody's whispering in my ear, is it humidity, relative humidity or grains?
Huh?
Grains?
Yeah, grains moisture, yeah. So that was another thing that these Liebert units came out with. They were measuring grains of moisture. I'd always have the guys come in with the sling psychrometer, you know. I said, listen, I like your sling. I got one myself. I said, but when you're checking it against this Liebert equipment, this is $100,000 piece of equipment, and you got a sling psychrometer that's probably, I mean, it's old technology, it's great, I love them myself, but maybe it's off by 5%. I gotta go with the Liebert unit. I'm sorry. Okay, I just gotta go with the expensive equipment, and then
Yeah.
then as all this digital stuff started coming out, if I had two pieces of equipment that said they were close to one another, I gotta go with that versus the sling psychrometer. And there's nothing wrong with sling psychrometers, they're great tools. I just, you start using this new stuff and,
Electronics is the way to go.
yeah, I mean,
You get one for $100.
yeah. Yeah, so, that's, but again, people don't realize, I look at the room, I gotta look at the ceiling, I gotta look at the floor, what's under the floor, what rooms are attached to it, what we're actually doing and how we're cooling that room. Is there supply and return lines that are off of like the building system in that room too? If there is, they gotta go. They gotta get shut off, or you're not gonna be able to draw straight lines.
Yeah.
That's just all there is to it. We have so many problems with, like, UH, the clinic, they're building all these pharmacies, and they wanna control humidity, but they don't wanna have a vapor barrier. The doors are left open. Yeah, the doors are left open, outside air, but yet they want 50% humidity. They wanna draw straight lines, and it's just not possible.
What do you mean straight lines?
Well, like a graph,
Oh, yeah, yeah.
that's all, They wanna see that thing go.
Yeah, yeah.
They don't wanna see it go up and down. As we start to, when we dehumidify, I gotta run the compressor. Does everybody know what I was talking about when I was talking about that? So, when I gotta run the compressor to dehumidify, because we don't run a slower fan, we're gonna drive the temperature down if you don't have the load. And that's one of the other things I must stress to you guys, that if you have a precision piece of air conditioning, try to match it to the load at least 3/4. 3/4, So if you got 100,000 BTUs, try to unit, the load should be at least 75. You just run better. Let's see what else I got. Any of you guys deal with like mini-mates or anything? Anybody have any questions on like small systems, units, Liebert? This just kind of gets repetitive, but you can see that this is a retractable roof, and it's electronic. So when the fire alarm goes, this thing just opens up, and you got the hinge doors. Cold in the middle, heat comes out.
How common is fires in computer rooms?
Electronic equipment, solder joint or something in the electronic boards and these servers go, or whatever the case. And then once you start that, those electronic fires, man, they just spread like crazy. And then we've had equipment that's caught on fire. The Liebert unit caught on fire because of the reheat. The unit's hasn't been maintained properly. Somebody's neglected the thing. Hasn't had a man, your company come in and do their thing. And, you got electric reheat in these things. That thing
Yeah.
catches on fire, melts down, plenum melts, it drops down on the servers. That's another thing, if you ever see a mini-mate in the ceiling, and it's got that plenum, those things, I hate them, because what do? Basically, they put air out the four sides and return it up the middle. And the air doesn't get to where it needs to be, so I'm a very big proponent of, anytime you put a small system in, or even a larger system, if it's an upflow, try to duct it, don't let it just free blow, free return. You know what I mean? So if I had a unit where Tom's sitting at, and it just free blows, and then this return is in the front where Tom's sitting at, if there's a piece of equipment here that's 6 foot tall, and the air comes shooting out, it hits that piece of equipment, the cold air is gonna go right back to the unit, return. Now the equipment down here is not gonna get its proper cooling. So, if I could duct that unit, bring it overhead, put some drops in, let that cold air fall, that's the way to go. So anytime you see a unit with those plenums, or if I have a levered unit on the wall and it's got a free blow plenum, and a customer is complaining about improper airflow, tell them, if I got the room here, I can build you a nice plenum, or a, what do you want to call it, a transition, or what would you call it, a ductwork, so you can drop down, and then put the air, again, put the cold air where it needs to be, get the hot air where it needs to be.
Sure.
Keep that in your mind, and I think you'll be okay. If you ever need me for assistance, you have my card, please call me. I'd love to be involved with you guys. I also do now, we rep Hitachi, a little sales pitch for Hitachi. Mini VRFs, mini splits, and Atmos, which is the air purification system. So bipolar ionization that actually works, and we can prove it. So unless you guys want to talk about something else, that's really what I got for you tonight.
If you wanna buzz through the bipolar stuff, that'd be great.
Sure, absolutely.
One in my house works fine.
Do a good job.
Yeah, we had, my son bought us a $200 toy that measures a particulate matter in the air.
Yeah.
It went down from 14 to 1.
Overnight.
That's what you want. You want to be able to measure it somehow.
Didn't you get the ion probe too? Phil?
Huh?
It's the one with the little thing that brushes off.
No, I'm saying the ion meter.
Yeah,
Didn't you have a meter for that?
yeah,
Yeah.
it does 4 things. It's a little size of a pack of cigarettes,
Yeah.
and it measures the VOC and particulate matter and whatever.
Yeah.
Okay, so Atmos company we started repping right when COVID came in. Everybody was going nuts for this stuff. Everybody wanted it, you know, and we had pretty good success with it. And they back up their claims. They actually can prove what it's doing. There was a big lawsuit on some of this other bipolar stuff that was being sold out there that they claimed was working, and they found out that it wasn't doing the job, and there's a big lawsuit even with the government.
It's a brand new.
I can't tell you. It was like,
Luke Hellman.
if I think about it a minute here, it was
There's a
called,
name, special name, we call it. I don't know.
let me think
Yeah,
about
you
it.
and I went through the program.
Yeah.
Yeah.
Let me think about it. Atmos, how it works, I don't know if this video will play, but
It takes little stuff in the air, agglomerates it into big stuff, and then it gets heavy and falls down and goes gets straight.
yeah, that's the whole thing, you wanna suspend those. But here's these customers that Atmos has been involved with, bipolar ionization with air monitoring, some big names there.
So what are you
Big
actually
cruise ships.
monitoring, Joe, when you say that?
I'll show you in a minute.
Okay.
So, I like this slide right here. We show outside air coming in, but basically, they show, I don't know if we can read this or not. I'm gonna get back here a minute. But here's the unit and how it's actually bringing the ionization in and what it's actually happening. We're after the coil. We're in the supply side. We don't want it on the return side, we want it on the supply side. And then these ionizations, these particles get suspended and they basically fall and keep the air pure. You know, no smell. A lot of people say that there's a ozone problem with these, but we kinda dispelled that whole thing.
Actually, it takes the ozone out of the air.
Yeah, yeah. So again, this was made for the virus and they're, you know, what this thing was all about and how they were beating it. And basically what they are is tubes. And these go into the supply side. Basically this sits on the outside of your air handler. And there are these glass tubes that do the ions. But here's what it does for you. Reduce dust and particulate matter, reduce odors, reduce mold, volatile organic compounds, bacteria and viruses, and improve energy conservation. So, kind of a better look at, this is kind of almost not an actual size, but I think I got a picture of them installed in some air handlers. The next slide or two. Yeah, here we go. So here's an in supply. And then here's another one where it's actually inside, I don't know how they put this one, but I don't know what I'm looking at here. Those are pretty big tubes, yeah. But anyway, that's the way they're supposed to be installed right there. Atmosphere is installed in any HVAC air distribution configuration,
And then,
whether it be in supply duct mounted or mounted in a supply plenum, okay.
maintenance on those tubes?
There isn't any. About every 2 years, you gotta change them out. That's basically it. So, these monitors that they have can be mounted remotely, like you could move it around, or you can actually mount it on a wall. We have a demo unit at the office that has probably like the size of the top of this, and it's got a monitor with it. So you can actually plug it in for the room if you want to bring it to a customer's and leave it with them for a day or two and show the monitor and, you know, and it shows how that has progressively gotten better. That scale, this thing goes from green to like purple or yellow to purple and then red as this number goes up. I am by far no expert on this stuff, but if you had a job where you think you might want to use this or quote it to somebody, I'd bring the right guy in for you. Because that's the last thing I want to do is give you wrong information.
Sure.
And then Hitachi, you know, basically I talked about this before. Just a quick overview. We have the heat recovery system or a heat pump system. And why choose a VRF? So if you had a, you know, we know why we use VRF. It's a building that's 7 stories and each room has a closet or something like that. We need cooling in, and I'm gonna use probably a VRF or a mini VRF. I can stick a head in each closet and keep it cool. And instead of putting like a mini mate in, where a mini mate costs 30 grand to put in, I put that whole VRF system in for you know, fraction of that.
Mhm.
The mini mate's 30 plus 30 for installation, 60, 70 grand. This thing probably cost you 15, 20 grand, and then whatever it costs you to put it in. And this is another thing that I like, a water source, so you can bring, tower water into it. And then the refrigerant lines hook up to this water source. So, basically, water in, water out. And there's the different heads. I like this unit here. It's like a multi-position air handler, almost like a stand-up unit. You can put either, you know, horizontal or vertical. I think if we come back, Tom, and we do we'll dedicate an evening to both the Hitachi and maybe the Atmosphere.
Okay.
You know, we could do that in a month if you want, or something like that.
I think we're booked into December now.
Huh?
I think the next one would be December that we're not booked to.
Let me know if you want me back for that. I'd be glad to, and I'll try and bring either the Hitachi guy or the Atmosphere guy with me.
Okay. Awesome.
You guys, good, or you wanna talk about, does anybody deal with the small systems, the mini mates? We gotta talk about those at all?
We got a couple. You know which ones I mean.
Okay.
Yeah.
Alright, just to let you know that the mini mates in the 3, 4, and 5 ton have been redesigned, so they have a variable speed fan, a digital scroll compressor, no more hot gas bypass. But if we have the smaller units, like the 1 and the 2 ton, then that's still a hot gas bypass unit with a fixed fan. So that's all in the process of being redone, the controls are being redone. And we have a little unit coming out called the wall mate. It'll probably be just like, you know, one of these things.
Those glass houses are gone, right?
Not really, they just evolved, they made them bigger, they made them stronger, so, they're actually making them now where it's a cabinet with a coil in it, and then the condensing unit's gonna be outside.
Okay.
So a little more capacity, but it ran its course, you know? How many customers really only have a rack that has maybe 1.5 to 2 kW? So, yeah, that's about it. How do we do on time? Are we okay?
Yes.
Yeah, 10 after 7, we're a little early.
It's all good.
Any questions? Who's gonna win the Browns-Steelers game?
Have to ask a football fan that.
Yeah,
Be on the
don't we have any football fans
Yeah,
here?
Of course,
Steeler fan?
absolutely not.
All right.
Joe, thanks.
You gotta understand where I come from with this stuff, because my company, I work for Donwil, is a Pittsburgh company, so Pittsburgh company bought the Cleveland office, and, you know, we gotta put
Where
up.
are you physically located?
Huh?
Where are you located?
Valley View.
Valley View.
Oh, really?
Yeah, we kinda been, we used to be Comback. Do you
Yeah, I
that name?
remember, yeah.
Yeah, and I work for Comback,
Uh-huh.
so I've been with,
I've watched it from there.
yeah, I've been with Liebert since 1986 in 3 different companies. Comback for 17 years, Liebert Direct for 10 years, and now 10 years with Donwil,
I tell you what scared the shit out of me, I had a brand new
37 years.
first year in business, and I landed this computer job, and I'm writing a check to Comback for $40,000. I'm shaking like this.
Yeah, it's kinda crazy, you know?
Yeah, I know.
Especially, cause our stuff was never cheap, it's always
No.
been the most expensive,
Yep.
so.
Always lasted the longest.
Yeah,
I don't think
yeah.
I ever gave.
Oh, no, you gave me one of these, you gave me one, thank you, thank you.
Got one from
Thank
the
you.
other.
Thank you, all right,
Thank you.
yeah, absolutely.
Appreciate it.
Thanks, guys, I appreciate you having me in, and, look forward to seeing you again soon. Thank you.